Hi, 8th graders. Today we're taking a look at Lesson 8, Similarity. Our target goals for today, that you'll be able to know the definition of similarity and why dilation alone is not enough to determine it. And given two similar shapes, you'll be able to describe the sequence of a dilation and a congruence that would map one figure onto another. So we've done both of these, so now we're kind of putting it all together. So let's take a look in your book. And we're looking at example 1, and it's page 83. On page 83, it says, in the picture below, we have a triangle, ABC, that has been dilated from center O by a scale factor R equals 1/2. It is noted by A prime, B prime, C prime. We also have triangle A prime prime, B prime prime, C prime prime, which is congruent to triangle A prime, B prime, C prime. So an example is triangle A prime, B prime, C prime is similar to triangle A double prime, B prime prime, and C prime prime. So let's take a look. And the question has said, okay, the first triangle we have here, we are looking and we can see here is our original triangle. And we're going to notice that it dilated by a scale factor of 1/2 to become this smaller triangle. Remember that because that scale factor is less than 1, we knew it was a shrink. And it was everything cut in half by 2. Now, we need to know what happened from A prime to A prime prime. So how did A prime get to A prime prime? Well, what did we do to get it from here? Well, we went up 1, so straight from our A prime, up 1, and then we went over to A prime prime. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 1 and right 10. So when we want to go back, because now we're going from this shape and we're getting it, how do we get it back to that? We want to move it back. So how can we do that? That's the question. Okay, so, well, let's do everything in reverse. Remember how we did that. Now, instead, though, of moving this back here first, we can go ahead and do that. We could also dilate this and then move it. Okay, so let's take a look at what the points are, and we're going to have to look at our scale factor and work in reverse. So we decreased it or shrunk our shape originally by 1/2. So to go the opposite direction, what would we have to do? Yeah, we have to multiply it by 2, because we know that to do the opposite or to undo what we did, we just do the reciprocal. So we're going to have to multiply this shape by 2. Now, we can take our ordered pairs, and we have on A prime prime 11, 4. So A prime prime is 11, 4. And we have B prime prime is 13, 5. And C prime prime is 15, 3. Now, to enlarge or stretch our shape, we need to apply our scale factor of 2. So A prime prime is going to become 22 and 8. So 22 and 8. Then we have 26 and 10. 26, 10. And our last one is going to be 30 and 6. 30 and 6. So that is our new points of our triangle. Mine is, there we go. There's our new triangle. And now, how do I get, because this right here needs to go to that letter A. How can I translate it over there? We would translate along a vector, right? Well, instead of making up a vector, how can I mathematically, I'm going to count, I can go right over here and count and then go down. So I'm going to go left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Left 20. And down 2. Could also have said down 2 and left 20. We could also have taken our points, which we notice are 22 and 2, and subtracted 22 minus 2, and that would have given us our left 20. So, describe the sequence. What was the first thing we had to do? Right, the first thing we had to do is we dilated. So we would write dilate, triangle, A prime prime, B prime prime, C prime prime, by R equals 2, that scale factor of 2, and then we're going to translate it, left 20, down 2. Let's go ahead and take a look on the next page. Okay, on the next page we have, it says triangle ABC was dilated from center O by a scale factor of 1/2. The dilated triangle is noted by A prime, B prime, C prime. Another triangle, A prime prime, B prime prime, C prime prime, is congruent to triangle A prime, B prime, C prime. Describe a dilation followed by a basic rigid motion that would map triangle A prime prime, B prime prime, C prime prime back on to ABC. So let's take a look. We're talking about our original triangles right here. Okay, here's our first one. And they dilated it and got our second triangle, which is here. The scale factor here was 1/2. And then they moved this triangle over to here. How can I get back? What do I need to do? Well, let's find those ordered pairs again. B prime prime is 4, 3. C prime prime, 5, 1. And A prime prime is 3, 2. Now we need to dilate. We need to get back to our larger shape. To get back to our larger shape, currently our scale factor that we had already used was 1/2. So our new scale factor is the opposite, the reciprocal of that. Well, what's the reciprocal of 1/2? It is multiplying it by 2. Yes, so scale factor is 2. So let's go ahead and change all of our points by a scale factor of 2. When we do that, our A prime, this B prime prime would now be a 8, 6. I'm going to go ahead and label it 8, 6. There we go. And then 3, 2 would now be 6, 4, because 3 times 2 is 6, 2 times 2 is 4, 6, 4. And our last one would be 10, 2, 10, 2. There we go. So that would be our new triangle. And now I need to translate it. So I'm going to look at this point, and here we go. I'm going to go from an 8 all the way to a -4. I need to put those together. So this would be 8 spaces. This would be 4. So altogether it is good 12, right? So we're going to go 12 left. 12 left. And then how many high do I have to go? Well, we're at 6 now, and we need to go up to 10. So we're going to have to go up 4. So overall, what is our description? What did we do? We dilated A prime prime, B prime prime, C prime prime. By R equals 2. Then translate 12 left and up 4. There you go.